Hey crew, today we're looking at power. And power, we're going to look at a couple different definitions here because there's several different ways to think of it. Your textbook definition, like if you just want, what is the standard, power is the rate at which work is done. Now let's break that down a little bit and see what it means. Power is basically how much work you can do in a certain amount of time. The more work you can do in a given amount of time, the more power you have. Another way of looking at it, since work is really a transfer of energy through force, we can look at power as being how much energy is getting used up in a certain amount of time. That's also a correct way of thinking of power. So again, three ways, two of which, these first two are pretty much the same, but power is the rate at which work is done, which really just means how much work gets done in a certain amount of time, or you can think of it as how much energy gets used in a certain amount of time. Either way is correct. Work and energy both have the same units. They're both measured in joules. All right. With the power equation, we say that power is equal to work divided by time. And pay close attention here because there's something that's going to get really, really confusing here in a second. But P is power, W is work, and T is time. So to calculate the power being used by an object is just the amount of work done divided by how long it took to do it. So again, power is work divided by time. Now, remember where I said this will get confusing? Notice that that W in the equation stands for work. So power equals work divided by time. These are the symbols that represent the different quantities. P represents power, W represents work, T represents time. When we talk about the units of power, remember, units are what we use to measure, or like behind a measurement to tell what kind of quantity we're dealing with. The unit of power is called the watt, and it's abbreviated with a capital W, just like we abbreviate work. So 1 watt of power means you're using 1 joule every second. So again, don't get confused. In the equation, that W means work. As a unit behind a number, that W means watts, which is the unit of power. So again, 1 watt of power is an object using 1 joule of energy every second, or doing 1 joule of work every second. There's also a second one that gets used in the United States fairly often. 1 horsepower is equal to 746 watts, or that is 1 horsepower is using 746 joules of energy every second. So just to give you some ideas of where this is used, light bulbs. It used to be that light bulbs used a lot more power than they do. Sort of the next thing coming down the pike are going to be these very low energy LED light bulbs. And for example, you see on your screen there an image of one of these LED light bulbs, and it's a 4 watt light bulb. So each one of these light bulbs will use up 4 joules of energy every second. Now compared to the old 100 watt bulbs that would use 100 joules every second and put out probably less light but a lot more heat, that's a pretty good deal. Looking at another one, let's take cars, and if we're talking about cars, we might as well talk about a really fast car. So the Shelby Supercar Ultimate Aero, here we have a car with the ridiculous amount of 1,287 horsepower. This car can go 250 miles per hour. Absolutely insane amount of power in this. But that 1,000 some odd horsepower means that this car does 906,102 joules of work every second. So that is the energy consumption of this car is 900,000 joules of energy every second that it will use. So things to remember. Power is how much work is done in a certain amount of time, or how much energy is used in a certain amount of time. The equation for power is that power is equal to work divided by time. And we have 2 units that we can use for power. The more scientific one is the watt, which tells you how many joules get used every second. And the other is the horsepower, which is equal to 746 watts. And there you have it.